Hello guys, once again, this is the 3.4 lesson packet. It's very quick. So there's only about 3 pages that I need to go over in terms of notes, and it'll probably be a lot less than that. So this is the last portion for chapter 3, and you know what that means, that the assessment is going to be sometime soon. Of course, I'll give you plenty of reviews. Like I said, it will be sometime next week. For this, the most important thing that you need to remember are leverage and influential points. This one you already should know how to do. We've already done linear regression and using the calculus and such. Reading computer regression tables, this is the big one. So what I suggest is that I print out a couple of these, print out this packet and just go over this with me. And you will see a lot of this in the next couple of days. I'm going to give you plenty of practices with this and making sure that you guys understand how to write down the equation from the computer data table. This one is mostly, this just an open-ended discussion question, so I don't really have to go over that, but mainly it's just these two that I really want to go over. So I'm going to keep this relatively quick. All right, so the LSRL goes through the points. This is the point that they actually go through, mean of X and mean of Y. They usually give you this just to indicate that it's one of the points that's actually on the line. So this point is 69,198, and this is at 52. But it's your X and Y. So that's what you have to put up here. Okay. All right. So now the leverage points and influential points. What's the difference? How do we determine them? So the low average points are close to, I think it's the mean of X. So I will just call it the mean. I always remember that leverage is close to the mean as much as possible. So we have a low leverage. Low leverage points, it does not, or do not, because it's plural, don't affect the LSRL as much. So what that means is that this particular point, it's close to, let's say, being in the center of where all the dots are, or the mean, or I think it should be closer to where this should be, this little red box. So if I were to, let's say, eliminate that point or add on that point, it's not going to impact the LSRL. It's not going to like tilt it one side or the other. It's not going to do any of that stuff. So high leverage points are far from the mean, obviously. High leverage points have some impact, I think. Yeah, or I'm sorry, high impact on the LSRL slope. So let's say I have a point somewhere up here. So then how is that going to impact it? Here, if I were to draw a couple of points down this way, then my overall line will kind of tilt towards the direction of where that dot is actually supposed to be. So we have a leverage in which all that means is how far is it away from the actual mean itself that is going to impact the LSRL. It's talking about the slope mostly because the slope, it shows you how steep it is. So if I have more dots like right here, then it's definitely going to tilt from the high end of the slope to a little bit more flattened out, because this point balances out all the points down at the bottom there. So that's what it means to have a high leverage. But you will be confused when I talk about influential because they are really similar to one another. What I want you to remember from leverage is that it's actually far from the mean itself. And I'll go over some questions tomorrow, going like, difference between leverage and influential points. There's not that many questions that deals with this stuff. So I don't want you to stress about it too much, but make sure you know the difference between leverage and influential. Influential points is points that if removed, changes the slope, y-intercept, or correlation substantially. Changes the slope when, if removed. It has really a lot much, similarity to leverage. The only difference, leverage is far from the mean, okay? So 3 types. It changes the correlation for the outliers. High leverage, it changes the slope and the y-intercept. So any point that changes the correlations or the slope is considered influential. So for example, there are actually 3. This is high leverage because look at all those 3 dots where that's located. Probably the mean is somewhere around those 3 dots, but this is far from the mean. So it's high leverage. Now, this isn't influential. Then the question here is that it's a no. Because if you take a look at where the line is, that dot falls right on the money where the line is. So does it change the slope? No. If this dot was like, let's say all the way over here, if I move that dot and then I draw, because I have to draw a straight line down like this now, then I actually tilted the line to be more flattened out. which will definitely change the slope, which will definitely make it an influential point. So then this point, green dot right here, will be considered a leverage, but it is not an influential point whatsoever because it does not change the slope. It does not impact the LSRL. As long as it changes the line itself, then it's definitely an influential point. Now, this is considered an outlier. Now, does this change the line? Absolutely. With these 3 dots in mind, this dot will actually tilt the line more closer to being in the negative side because this dot is so down there. But how about the leverage? Well, the mean is somewhere over here, right? I mean, if I were to calculate the mean of those 3 dots, that dot is really not that far from the mean, the center of where all those dots are. So this one actually does not have a leverage, but it's definitely an influential because it can change the line. Now, this is both. Look at all the dots are. The mean, it's definitely bigger. So the dot is actually far from the mean. So it's definitely a leverage point. Is it an influential point? Yes, because this dot will tilt the line in that direction. Remember, that line is the best line of fit. How much can it, go through that incorporates all the dots? We want to make sure that our regressions, or we like to call them residuals at this point, we want to mitigate the residuals as much as possible from all the dots. So this is a leverage and influential point, both happening at the same time for this particular graph right here. Okay, so this 3 examples should probably provide you with a much deeper understanding and just kind of give you the picture of which is what. In order to practice these problems, obviously you need to just kind of go through sampling questions. I will assign you guys that tomorrow though. Okay, I'm going to skip this because you guys already know how to do linear regression. For the last part for today, I'm going to go over reading computer regression tables. And this is very, very important. For reading computer regression tables, I want you to remember just one thing. This is all garbage. It's trash. We don't want to look at that right now. There are some components in there that in the future that might be useful, but for right now, you're only looking at the coefficient portion, constant and income. This one, I want you to always remember as an explanatory variable, by the way, and it's not going to change. So that income is always going to be your X. S, this is your standard deviation of your residuals. This one is your least squares regression, R squared, R squared. Remember, that's R, which is your correlation squared. Yesterday, we talked about how we can describe R squared. This is called coefficient of determination. So you can say 61.7% of the variation due to the response variable can be explained by the least squares regression line. That template that I went over, please study over that, okay? The R squared adjusted, that also is trash, so you don't have to look at that. So only numbers that you're looking at are these 4 components. So what do I do with these 2 numbers up there? Well, you're going to create a linear equations from this, and you need to understand how to be able to do this. The very first number that you see is negative 14.7. That is always going to be your A value, okay, or your y-intercept, if you will. And the B value here is the one that comes after 0.001x, like this. So that is your slope. So whatever this number is, that's your slope. Whatever this number is, that's your y-intercept. And if you take a look at the equation from the answer key, it should provide you with the same thing here. Now, to write down the actual answer to this, the way that you're going to write it is, I need to be provided with the response variable for this one. But usually it should be y hat is equal to negative 14.7 plus 0.001 times the income. And the y hat, you need to actually input the context they provided for you. So let's say that this is income, and I don't know, this is your, I don't know what other context I would say, but whatever the context that they gave you, you put a little hat over it, and you're going to write negative 14.7 plus 0.001 times the income. I don't know, the number of houses. So you're going to write number of houses in your, that's a terrible example, but any context, any word context that they gave you as a response variable, you're going to literally write word for word there and put a little hat over it. And that is how the least squares regression line, or the best line of fit equation, will come from this table. Okay, so that's pretty much it. I want you guys to just take this as a grain of salt and just kind of soak it in. Tomorrow, we're going to practice this and how to utilize this. Right now, what I want you to do is to be able to formulate the equations just strictly from the computer regression tables only. All right, I think that should be it. I'm gonna skip this prediction as a discrimination. That's just for discussion, open-ended question. You can take a look at the answer key, of course. And after that, I think that should be good. Take care, have a good day. Today, the main objective is for you guys to do free response question and making sure that the answer is fine, and also writing down the notes for 3.4. And tomorrow we'll go over some questions. All right, thank you. Have a good day.